Problem number 8. The velocity versus position plot of a particle is shown to the left. Which following choices is the correct acceleration versus position plot of the particle? Solution for problem number 8. The equation for this graph, velocity versus position, is v equals cx, where c is constant. Let's take a first derivative for both parts. That will be acceleration a equals cv, but v equals cx. It means that acceleration equals c square x, and this exactly linear dependency, which is graph C. So that was the answer for problem number 8, graph C, and that was solution for this problem number 8. Problem number 9. A block of mass m is attached to a massless string. The string is passed over a massless pulley, and the end of the string is fixed in place. The horizontal part of the string has a length L. Now a small mass m is hung from the horizontal part of the string, and the system comes to equilibrium. Diagram not necessarily to scale. Neglecting friction everywhere, the tension at the end of the string is next one. Solution for problem number 9. In equilibrium, the tensions on the both sides of any pulley must be equal for torque balance on the pulley. The same logic applies to the mass. One can think of it as just another pulley. Hence the tension everywhere in the string is mg. That was answer B, and that was solution for problem number 9. Problem number 10. During this process of problem number 9, the block has been raised by approximately a height of which one? Solution for problem number 10. For force balance on the pulley, the strings must attach to it at an angle of 30 degrees to the horizontal. This also implies the mass must be placed at the middle of the horizontal section. Hence, the horizontal section of a string, originally of length L, becomes two tilted sections, each with a length L over square root from 3. The change in length is L multiplied by 2 over square root from 3 minus 1, which is approximately 0.15 L, which is equal to the increase in height of the block. That was answer A, and that was solution for problem number 10. Problem number 11. The maximum tension per area a material can sustain without failure is called its tensile strength. Plain steel has a tensile strength of 415 megapascal. What is the maximum mass one can hang on a vertical steel rod of negligible mass and a diameter of 2 centimeters? Solution for problem number 11. Tensile strength equal force over cross-sectional area, and the force equal mg. So we have tensile strength P equal this expression, and from here we can find what is this critical mass. That will be tensile strength multiplied by P multiplied by R square over G. And after putting numbers, we have approximately 13,000 kilogram, which is answer C, and that was solution for problem number 11. Problem number 12. A point mass M is glued inside a massless hollow rod of length L at an unknown location. When the rod is pivoted at one end, the period of small oscillations is t. When the rod is pivoted at the other end, the period of small oscillations is 2t. How far is the mass from the center? Solution for problem number 12. Suppose that distance from one end is x. So it means that period for this location is 2 pi multiplied by square root from x over g. If we pivot it to the other end, we have 2t equal 2 pi multiplied by square root from L minus x over g. Let's square both equations and divide the second equation by first equation. We have L minus x over x equal 4. It means that x equal L over 5. And the last step is to count what is the distance from the center. That will be L over 2 minus L over 5, which is 3L over 10. And this is the answer D. That was solution for problem number 12.